Okay class, today we are going to study about solvent extraction. Solvent extraction, it is a technique that we have been using since ages. How our grandmothers also used to use this technique for purification and separation of various household materials. This particular technique utilizes the principle in which two immeasurable liquids are standing close to each other such that the solution or the sample that is to be purified is getting separated based on their nature on two things. Either the product of interest is, it could be either hydrophilic or hydrophobic. What are these two terms? Hydrophilic means, hydro simply means that it is in concern to water. Philic means that it is having affinity to it. All the materials, those are hydrophilic. These are also in our general terms, these are termed as hydrophilic, means water loving. All the molecules that are hydrophilic are easily dissolvable in polar solvents like water, etc. And the solutions which are non-hydrophilic are termed as hydrophobic. Hydrophobic means that they are all having phobicity for water. It simply means that they are least dissolvable in polar solvents like water. Example of some of those chemicals are like benzene, etc. So, utilizing the this particular principle, we have got a purification technique, that is solvent extraction. As it is given into this diagram, we are having two types of solution, the solution A and the other one is solution B. One of them is actually hydrophilic and the other one is hydrophobic. You can consider the example as we have we can mix the water and some kind of oil. We have mixed it together. We have shaken up the flask very well, and we will allow it to stand for some particular point of time. So what will happen after that particular period of time? After that particular time, the two solvents will be separated according to their density as well as their affinities for water. So as we see in that particular example of oil as well as water, the water will settle down and the oil, if it is lesser than water, then it will float over to its surface. Similarly here, the denser material will sink down and it will be followed by the lighter one. How can we utilize this particular technique for purification purposes? We must know that the product of our interest, is it soluble in the solvents like which are polar in nature, or either they are more soluble in solvents which are hydrophobic or which cannot be easily dissolved into the polar solvents. What are we going to do? We simply going to pour the sample into it, the whole of the material which is containing the sample of our interest. After pouring it into this particular vessel, we are going to shake it thoroughly. After shaking, we will allow it to stand for some time. What will happen? If the product is, let's say that the product A is, it is hydrophilic, means it will dissolve all the polar type kind of solvents, and whereas the sample that we have, the solution that we are using it, like this B1, it is hydrophobic. It will dissolve all the non-polar kind of materials into itself. If we have added certain kinds of proteins to it or certain kinds of amino acids to it or other molecules, so they will be separating on the basis of their hydrophobicity or the basis of their hydrophilicity. How? If they are more hydrophobic, they will be completely dissolving into the B phase, or if they are completely hydrophilic, then they will be completely dissolving into the A phase. And what if the molecule is having equal amounts of hydrophobic groups as well as hydrophilic groups, then it will be settling down in this particular phase, the phase that is in between the both kind of solution, that is between the phase which is in between solution A as well as solution B. So how are we going to separate them? We, after the proper standing time, we are directly going to open the tap. First of all, the solution that is present in the bottom will come out. We will harvest it up till this particular phase. When this particular solution is being removed, particularly, we will change the beaker. Then in the second beaker, we will take this particular phase which is underlying between the two phases, that is between the phase A and between the phase B. Once the second beaker is been removed, then we will place a third beaker and we will again turn on the tap in which we are going to collect the sample A. So on the basis of this particular principle, we have got three kinds of molecules. First one, the hydrophobic one. In this particular example, the B phase will containing equal amounts of hydrophobic as well as hydrophilic groups, and the third one will be having the hydrophilic molecules. In this particular way, we can harvest out the three different kinds of molecules. Nowadays, we have this particular technique, and there are very many modifications of this. Like for this particular extraction purpose, we are using techniques like supercritical fluid extraction and superliquid extraction. What are supercritical fluids? In the supercritical fluids, the state of matter in which the matter behaves like a fluid, like in the example of helium. Helium under certain conditions helium itself is a non-reactive kind of element which we are having. The helium gas is less reactive, and once it is converted into its liquid form, how are we going to convert it? We are going to provide it with higher pressure. In that particular high pressure, the helium will be converted to liquid state, and in that particular state it will behave like superfluids. And these kind of superfluids are having various advantages, like it will be having minimum friction, which will cause a different kind of extraction method. And helium itself is non-reactive, so it is very good for this kind of extractions, wherein it is going to directly enter into the matrix that is containing the product of our interest. Then it is directly going to elute out, and it will carry with itself the product of our interest. The whole of the matrix will be standing. Due to its less frictional force, it can directly move through it, and it will carry out the product of our interest. Next kind of variant is the supercritical fluid extraction. What is supercritical fluids? At certain point of time, the gases like carbon dioxide, which are usually present in our atmosphere, under particular temperature and pressure, these are converted into supercritical fluids. What are supercritical fluids? In which they are having various kind of advantages. Like for carbon dioxide, we have 31.1 degrees centigrade, and at pressures like 7.38 megapascal. At these kind of temperatures and pressure, carbon dioxide will have certain advantages. It is also going to react in the same way, and once it is going to take out the product of our interest out of the matrix, then we can directly reduce this temperature, or we can alter the pressure back to the normal, and ultimately the carbon dioxide from its liquid state will transit into the gaseous state. What will be the benefit? Carbon dioxide will be directly liberated into the environment, and what we are having with us, the ultimate purified product that we were requiring. So this is the objective of using these two kind of variants of this particular primitive type of technique, that is solvent extraction. So that is all.